Hey everybody, and welcome back to another fun and exciting pre-algebra class. Today we are going to be continuing in 7.5. We're going to do just a little bit of graphing, and then we're going to do some word problems with this direct variation. So hopefully you can follow along. Make sure you have a piece of paper out. Make sure that you're taking notes on this, and make sure that you're actually doing the problems with me. Why should you do the problems with me? Because then when you try to do them by yourself, then you will have just the work right there. You can just look back at the steps, and hopefully that will help you get the next one right that you try by yourself. Okay, so do it with me. Be an active learner. All right, look in your book down on page number 318. 318. You'll see there example 7.5. I'm going to show it on the screen as well. Y equals 1/2 x. So what we want to do is we want to go ahead and graph this, or try to graph this, I guess. You can't graph all of the direct variation problems, and we're going to talk about that in a second, but let's try to graph this and see what happens. So what we want to do is take this right here, this y equals 1/2 x, and we want to put it onto the graph. Remember, we do not have, in direct variation, we do not have a y-intercept. We don't have a plus b. Remember, because our b always equals 0. So in this case, we could just say that b is going to equal 0, or our y-intercept is going to equal 0. So that means that this is going to be graphed right here at origin. So in these problems, we're always going to have a point at origin. Then you come over, all you have to do is come over here to the slope. Remember the slope, the m equals our k, that's our constant right there. So in this case, our constant is going to be 1/2. So we would come over here and we would go up, because this is our slope is always y over x. So we go up 1, so go up 1, and we're going to go over 2, 1, 2, and there's our point right there. And after we get that, we're ready to put our line on there. So then you come over here and get a line and throw your line up there. There you go. And that is as easy as it gets when you're graphing. Goes through origin, 0. The slope is 1 over 2. So just y over x, go up 1 over 2. You got your line. All right, next, let's look down here at this next. This is actually on page 319. Not really going to teach this too much. I'm just going to talk about it so that you kind of know this word. And then later we'll learn more about this. But not all linear equations are direct variation. In other words, sometimes you have a y-intercept, right? Remember that if the y-intercept is not 0, then it's not direct variation. So whenever you have a y-intercept, so whenever you have a b, so y equals 1/2 x plus 3, for example, when you have that plus 3, that means that this is not going to be a direct variation. So this is just going to be a regular linear inequality if you have a b. Now, these types of problems, and this is again from page 319, these types of problems are called non-proportional. Non-proportional. So we're only dealing with the proportional ones, or we're only dealing with, in this lesson, the direct variation. So we'll kind of circle back to this right here, this concept of non-proportional later. But for right now, I just want you to know that word. Make sure you understand that word right there, non-proportional. That means that it does have a y-intercept, and it is not direct variation. Okay? All right. Next, let's solve a few word problems with direct variation. What is a word problem? Well, it's a problem with words, okay? And so it's got like a story problem. It's got like, Bob went to the store, these problems, okay? So how are we going to solve these if we're dealing with direct variation? What are we going to do? Number one, we want to find the constant of variation, or in other words, we want to find our k equals what? Let's solve for k. Let's find k. Now, I would actually say let's find x and let's find y as well. Let's see what those two equal as well, because then once we know all three of these, then we can do number 2, write the direct variation formula, and then we're going to plug into it. So what is the formula? Y equals kx, right? And so now what we want to do is we want to plug into that thing. So we're going to plug our x in, we're going to plug our y in, and we're going to plug our k in. So read the problem, determine, okay, what's my constant of variation? What's my x? What's my y? And then you start plugging it into that formula. Always go back to this formula. That formula is key when you're solving these. And then next, the last thing that you're going to want to do is you're going to want to solve the direct variation problem for each independent variable. So many of these problems are going to say, okay, so if Bob paid $8, okay, for his groceries, and Sam paid $12 for his groceries, and whatever. And then you have to find out, you have to say, okay, what did Ted pay for his groceries, for example? And there'll be more to the problem than that. They'll tell you how much they bought or whatever. So that's kind of the idea there, is that we're going to solve for the missing person or the missing independent variable. Okay? So let's look at one of these. Let's just practice. All right, here we go. All right, this example is on page 320, and it's their example 7.5D. A feed store sells oats by the pound to local farmers. Judy, Carl, and Ruby all bought different amounts of oats. Write an equation and solve for the cost of the oats per pound. Then find the cost if John bought 60 pounds and Eddie bought 160 pounds. All right, so let's identify the K. What is our K? K equals what? That's step number 1, right? That's what it told us to do. So find the constant of variation. So here's what Judy bought, here's what Carl bought, and here's what Ruby bought. What we can do, here's the way that you find the constant. You take any one of those, and it doesn't matter which one. Now, we probably want to do it to multiple ones, because remember this when we went back up here. Remember, these can be non-proportional. Here's what non-proportional means. That means that none of these would have the same constant. They would all have this, if there's non-proportional, all of these are going to come out to different constants. Your constant will not be the same. So if we have the same constant, then we have a direct variation. Remember, because it's direct variation, right? It varies directly. This constant is what makes it vary directly. So what we want to do is we want to take these and we want to just divide those out. So in other words, we have y equals kx. So if in this case we make the pounds the x, because that's our input. That's how many pounds they bought. So if we make pounds, LBS, equals that's our input, right? That's our x. That's how much they bought. The k is going to be the constant, or the whatever's varying. And then what our y is going to be is the cost. How much did it cost the farmer? So if Judy bought 50 pounds, all right, that's how many pounds. So that goes in for the x. The $22 is our cost, and so that goes in for the y. So watch this. $22, and we'll just leave it at 22. We don't need the 0.00 on that. Well, I'll put it, but equals kx. We don't know what k is, but we do know what x is, 50 pounds. Now, if we divide both sides by 50, we will get, in other words, that cancels, we will get k by itself, and we will find out the answer. Okay, so one way that you could do this is just divide this right here, and 220 or 200.20 divided by 5 is going to give us 420, 4.4 or 4.40. So our k is going to be 4. Let's get rid of this question mark. Now we know the answer. Our K, our constant, is that it cost $4.40 per pound. Okay? And we found that by dividing that. Now, let's verify that. Let's make sure the K is the same for all of them. Okay? Because maybe we don't have direct variation. Maybe we have something else going on. So we can find that by going ahead and dividing this next one. Does this do the same thing? So Carl is 80 pounds, so X is 80, right? There's our K again, and we equal 3520. 3520. Now we're going to try the same thing. We're going to divide both sides by 80. I'm going to cheat on this one. I'm going to use my calculator for this. I don't feel like doing this. So 3520 divided by 80 equals, I got 0.44. Now I've got a problem because over here I got 4.40. I'm going to show you something that math teachers can make mistakes too. When I divided this one out, I messed up my decimal point. So this is actually 44 cents, not $4.40. And I'll show you that to you on the calculator because we'll just go ahead and do this one again. So on this one, we'll do 22.00 divided by 50. And it's 0.44. So I'm sorry, I messed up my decimal. Maybe some of you noticed that, and so good job. You beat the teacher on that one. So every once in a while, I make mistakes too. That's why I really like to check myself with the calculator just to make sure that I don't make a mistake there, okay? If we did this one Ruby, we would also find that it is also 44. In fact, this is a direct variation problem, so we actually do have the constant of variation, 44 cents. Now, the rest of the question up here, this is kind of like, this is the finish. We're going to finish solving it by solve the direct variation problem for each independent variable. Look, we have more independent variables. John bought, actually that should say T right there. John bought 60 pounds. John bought 60 pounds. So we need to find out what John. So let's find out John. He bought 60 pounds. So we know that his X is 60. And we know the direct variation, the K, is going to be 44. So 0.44 times 60. And that's going to give us our Y for John, or our cost for John. All right. So again, let's just switch back to the calculator. 0.44 times 60 is going to equal, John paid $26.40. So John equals 26.40. Let me make sure that was right. Yes, 26.40 for his oats. And then we need to find Eddie. What did Eddie buy? Eddie bought, here's Eddie, 160 pounds. So now we're going to switch this over to Eddie. Farmer Ed, what did Farmer Ed buy? Good old Farmer Ed bought, his cost is going to equal that 44 cents, right? Because that's the constant. That stays the same throughout the problem. He bought 160. So we'll go back to our calculator now, and we'll plug that in. 0.44, that's what it costs per pound, times he bought 160 pounds. Ed paid $70.40. $70.40. And you can see that in your book there, and you can kind of look through that. That's on page number 320. You can look at it there, and you can rewind that and look at it again on the screen if you need to. Okay? Well, that's all I have for you in this lesson. Hopefully you kind of learned how to plug it in there, how to find the constant, and then how to find the other variables based on that constant. So practice these. There's lots of practice problems there in your book, and have fun with this, okay? Math can be fun. Yeah, it really can be. Some of you are like, no, it can't be fun. It can be fun. So have some fun learning how to solve these direct variation problems. You could also graph these if you wanted to, okay? Have a good one. We'll see you later. That's all I got for you. Bye-bye.